Awesome. So yesterday we started with a particular design pattern. What was it? Which design pattern did we start with? Bridge design pattern. Exactly. So let's quickly talk about what we had already discussed yesterday. So we won't invest so much time in this. We'll just quickly revise it and move ahead. Okay. So we already saw a lot of it. The case that we started from was this. So basically, let me write this again. So we said that there is Uber. Now Uber has, say, Uber Ride and Uber Eats. Yeah. And both of them need navigation system. Both of them need navigation system. So say you want to let user choose that in Uber Ride, what navigation system do they want to use? Is it Google Maps or is it Apple Maps? Similarly, for Uber Eats also, you want them to choose. So how do you do this? There are basically two parts to this. So this is the implementation part, right? Where the actual navigation implementation is happening. And you call this as the abstraction part. This is the core. This is where we are using the implementation, right? So how are we going to do it? So like, how is the UML going to look? Okay, let's look at the UML. So if this is the abstraction, okay, so abstraction means like Uber for now, and it will have the implementation, right? So have the implementation meaning what? What relationship is it? Guys, what relationship? I want more people to answer. Come on. Has a, correct. And there will be some function inside this. In our case, it will be say navigate, right? Navigate or something like that. So this is a has a relationship. And what is this thing called? This is called implementer, right? And implementer will have what? It will just have the implementation, say do the navigation, right? And then there will be concrete implementers. So if I draw one concrete implementer, right? And obviously because implementation is interface, so if this is interface, this will also have the implementation. Yes, so in our case, like Google Map or Apple Map, it will actually do the implementation inside the concrete implementer, right? But where are we using it? In the abstraction. So abstraction is say Uber or Uber Ride or Uber Eats. So obviously there is one concrete, or say in this case, it is called refined abstraction. These are just names that are given like for the design pattern, but I guess you are able to understand, right? Everywhere, just think of it like, okay, interface, we have to follow ISP, create as small interfaces as possible, make it extendable, maintainable. So here abstraction was what? Uber. So now it has two parts. So now there will be Uber Eats and Uber Rides, right? So refined abstraction, and the function is going to be there. That navigate. Yes. So what are we trying to do over here? We are going to separate out the implementation and the abstraction. And again, here, if you notice the point that we were just discussing and like while we were revising. So here there is again has a relationship, right? So again, has a is a good practice. Like it solves a lot of problems for us. And creating interfaces, as you saw, that implementation is there, abstraction is there. It also solves a lot of problems. Okay, let's quickly discuss how does it follow solid principles. Let's quickly discuss. So how SRP is being followed? Implementers are separately. The ones who are using the implementation is separate. So we are following SRP. Yes? Make sense? Can I get yes? Yes, we are following SRP. How are we following OCP? We can add more concrete implementer. Tomorrow, if there is, say, some more, Google is there. Suppose Microsoft also comes up with its maps, Microsoft Maps. Okay, I can easily add it, and then these guys can start using it whenever they want, right? So OCP. Similarly, I can add another one. Suppose there is Uber Ride and Uber Eat right now. Suppose Uber opens its own Amazon and calls it Uber Amazon or Uber Delivery or whatever. Then they can easily add it from the abstraction, correct? So OCP, because we can extend and we can add new features without changing the present features, correct? How is it following LSP? So all the refined abstraction, basically wherever you use Uber Ride or Uber Eat, you can use the abstraction. Basically, you can use Uber. Sorry, opposite. Wherever you are using Uber, you can use Uber Ride or Uber Eats. Yes, LSP is clear? No, guys, any confusion? First week? Yes, yes. Similarly, everywhere we use the implementer, like everywhere, suppose I use maps, I can use Google Maps and Apple Maps, right? Similarly, everywhere I use Uber, I can use Uber Ride or Uber Maps. What am I saying? Uber Ride or Uber Eats. Wherever I use maps, I can use Google Maps or Apple Maps. Yep. Cool. How are we following ISP? We have created small interfaces. One interface for implementation, one interface for abstraction. Yes. Shobhit is saying, why should we need LSP? How is it useful? See, solid is the guideline. Firstly, you should follow solid as much as possible. And how are we following LSP over here? We are following because everywhere where you can use the base class, you can use the derived class instead of that. So that is what LSP says, that it is extendable. And that is what actual inheritance is, that everywhere you are using the base class, you should be able to use derived class because we're just extending some more properties. We are just adding some more things. Yes. Sorry, I missed why we have abstract instead of interface. So, okay. Firstly, it is not that this cannot be interface. It can also be an interface. The term that is used, basically abstraction is basically the term that is used, that this is the implementation. Don't go behind the term abstraction versus interface. This abstraction means that we are using the core of the design pattern, where we are using the implementation. This is not abstract class versus interface wala. Okay, so don't get confused between those two. So yeah, got it. No? Okay, cool. So D is again dependency inversion. So here you can see we are not depending on low-level modules. Like the abstraction is also dealing with the implementation, basically with the interface. And like nowhere will we come to know that what is the concrete implementation we are using. Like in the Uber Ride or Uber Eats, nowhere we will use that we are using Google Maps or Apple Maps, right? Everywhere we will just say that we are using maps. Ash is saying, can you please repeat the problem statement? Ash, we did it yesterday and we just did it again, but okay, cool. I'll say that again. So the problem statement was that we have Uber, we have Uber Ride, we have Uber Eats. Suppose tomorrow there is Uber Amazon. We have like a lot of branch subsystems of Uber. All of them use navigation system, right? Suppose I make them like this. So it will be like Uber Eats is using Uber Eats Google Maps and Uber Eats Apple Maps. Similarly, over here also Uber Ride is using Apple Maps and Google Maps, right? So we will have to create so many classes. So instead of that, we discussed yesterday that we can use bridge design pattern. In that, what do? We separate out the abstraction and the implementation. Implementation is where the actual stuff is happening, where we have the implementation logic. Basically, we have the navigation logic, right? So that is the navigation system for us. And then wherever we are using the navigation system, that is called abstraction part. So that is Uber Eats or Uber Rides in our case. Yep. Paris is asking, I didn't understand this much, why we can use a strategy here to choose correct navigations. So strategy is basically different algorithms, right? That you want to decide runtime. Here, what am I doing? Here I am saying that there is basically an implementation that I want for both the systems, right? So there is like common implementation for Uber Eats also, for Uber Rides also, right? So I have common logic over here. So Uber Eats. So firstly, the Apple Maps logic is irrelevant of Uber Eats or Uber Rides. Similarly, Google Maps logic is irrelevant of Uber Eats or Uber Rides. We are just using that logic, right? So in strategy, it was more like it was a specific to where we are using it, right? And runtime, we were making decisions. Like over here, bus, like if I make any changes in bus, I should be able to produce it and assemble it separately. Let's take more examples. Like for example, we have, say, payment. Okay, so if we have payment, we can have PayPal, we can have, say, Paytm, and we can have GPay, right? Similarly, over here, there is Uber Rides, and there is Uber Eats. And see, the problem is not that we want to change the behavior. The problem is that we want to structure it properly. Just listen to this very carefully. The problem here that we are trying to solve is that we want to solve the structuring. Like Uber Eats can use all the three payment systems. Uber Rides can use all the three payment systems. Uber Eats can use all the three payment systems. What was the problem? What was the intent of strategy? That there is just one place where we are trying to use different algorithms. That is, we don't want behavior to be changing. That is okay. But how do we structure it? How do I structure it? Now, there are two components or two refined abstractions is the term to be used over here, who are using the same implementation. They can. I am asking you, how will you structure this? Okay, if you want to use a strategy, now how would you structure Uber Rides, Uber Eats using these different, in your terms, of strategy? Just think about it and you will come up with the same UML that will look like bridge design pattern. Paris is saying, got it. Cool. Let's look at the code also once more. Another example, by the way, in Amazon, suppose we have search engines, right? So if suppose Amazon, so we have, say, Amazon India, which is .in, and then there is .com, correct? The US one. Now in this, we are using search. Now, suppose in search, we can have different search engines like search engine 1, search engine 2, search engine 3. Now, .in might want to use this or this or this. Now, .com might want to use this or this or this, right? So this can use all three and this can use all three. So how are you going to structure it? So what we are saying is that put this subsystem separately. This is the abstraction part. Put this subsystem separately. This is the implementation part. And Amazon, the abstraction will basically have the implementation. So here we saw, right, that abstraction has implementation. So it has implementation, and how it is implemented will be taken care by the concrete implementer. Who is the concrete implementer in our case? Search engine 1, search engine 2, search engine 3. Guys, do you have any confusion in this? Let me quickly show you the code because we had covered most of this yesterday. Let me just show you. Whatever doubts you have, please mention in the chat. I will try to clear it from the code itself. Yep. Okay. Everyone can see the code. Bridge design pattern. If we see over here. Okay. So this is the implementation layer, the navigation implementation. What are the two implementations? One is Google Maps. One is Apple Maps. This much everyone is able to understand that there is one implementation layer, navigate to. So this is the abstract method. If you see over here also, this is the navigation implementation and these are the concrete implementations. So basically Google Maps and Apple Maps. So everyone can understand that navigation is being taken care by this. Is everyone able to understand this much? Any doubts in this part? Any doubts in this part? Any doubts in this part, guys? No? Can I move ahead? Someone is saying this is like abstract factory. So abstract factory, what was the problem we were trying to solve? We were trying to create family of similar objects. Are we creating anything? No. We are using some implementation. Yes, if you see about the structure, you're going to say that it is similar to abstract factory. But what was the intent of the abstract factory? Creation of family of similar objects, right? What is the intent over here? We are separating out the implementation and the abstraction. The intent is the key point. Okay. See, I guess we have done so many design patterns. By now, you might have understood more or less. If you sit and design for the same problem following the solid principles, I am sure you can design these design patterns. If you sit that, okay, this is the problem statement, I have to follow solid principles, you will end up with this only. But this makes life so much easier because the moment you think that, okay, I have to use command or, command is an object, I will use command design pattern, or I have to create family of similar objects. Okay, adapter design pattern, complex creation, steps is there. There is a director, but I know that the steps are same, but similar objects, complex similar objects, builder design pattern, right? So because you know the design patterns, it will become easier for you to communicate, say in interviews, in daily work, you will just tell your manager that, okay, I'm going to use abstract factory. Or we will learn today, I'm just going to create a facade. I'm just going to create a proxy. I'm going to create a composite design pattern. We will learn these three today. right? You will be able to come up with the same design yourself also. The point is that these are the common solutions. And it makes sense, right? That implementation is separate. And where you're using the implementation is separate. This is where you're using the system. So navigation system, basically just call it Uber. There is Uber Ride and there is Uber Eats. So you can see in both of them, there is navigation implementation. So this is has a relationship, has a, right? Because it has. Now, what we could also do is that this navigation system, this implementation, I could keep it here itself and I could keep it protected. So now Uber Ride and Uber Eat can use it. In Java, I've just kept it like separately over here. But I could have also kept it over here. I could keep it protected, or I could, I could keep it protected or public. Better to keep it protected. I'm just showing you that this is not the crux of the design pattern. What is the crux of the design pattern? That Uber Ride and Uber Eats has navigation implementation. So it is better to you keep it in the abstraction layer itself. Over here we have it. So both of them will have, like Uber Ride will also have and Uber Eats will also have. Then they have this navigate and set navigation implementation. This is how it is. So if you see over here, on the fly, I can see that there is Uber Ride, there is Uber Eats, and then there is Google Maps, Apple Maps. So on the fly, I can decide that I want to use Google Maps or Apple Maps, and I can navigate. Let's run it also. I guess it will be clearer then. Let me just run it. So if you see over here, Uber Ride with Kirti to Central Park using Google Maps. So here I did what? I just said navigate to this Central Park using Google Maps. So I set the navigation to Google Maps, right? And here I am Uber Eats. So I am saying Uber Eats to 123 HSR using Apple Maps. Now suppose here I change from Google Maps to Apple Maps. Let's see what happens on the fly. So I'm changing only in one place. I'm just changing the navigation implementation in one place. Okay, let's see. So now this should become Apple Maps. Does it happen or not? Let's see. So here Apple Maps happened, right? Now suppose the below one, I want to use Google Maps instead of Apple Maps. And instead of this, I want to go somewhere else. Suppose I want to go to ABC place. Okay, let's run it and see. So you can see that I am going to ABC using Google Maps. See, so the point is that I am telling runtime that this is the navigation implementation that I want to use. And right now I am using for Uber Ride, I could be using for Uber Eats. So not just you are changing the implementation, the navigation implementation runtime, but you are also changing what that I am using Uber Ride or Uber Eats runtime. Cool. Okay, I am going to let you guys unmute yourself so that you can ask me any questions. But I will let you ask only for 5 minutes because we have 3 design patterns to cover today, and I will not let you go until we finish that. Yeah, 10.
Yeah, Kirti, why do we need abstract class over here? Can't we directly write concrete class and we can make hazard relationship of navigation?
If we have Uber Ride and Uber Eats, so you are saying that we will force them to have this navigation implementation, no? And we will force them to have this navigate. Isn't it better to why do we create interface? So that we tell them that you are forced to have this function navigate, right? Both of them should navigate. Uber Eats also has, Uber Rides also have, right?
Any class in the future, if also comes, they can have the similar interface.
Yes, OCP.
Yeah, but actually the concrete class is not implementing the navigation logic, right? It would be using navigation implementation to call the navigate method, right?
Yes, so we can have this. In fact, like you could have like good question. Like another question could have been that I could just navigate from here itself. Like if I have the destination, I can navigate from here itself. Like they can, this part navigate to, I can have it inside. Like I can have a common implementation, in fact.
If it is common, then it makes sense. Yeah.
So yes.
Otherwise, I thought, okay, if because we are using navigation implementation to navigate, right? So I thought if you do not use abstract class, my concrete class knows. I mean, whichever concrete
The
class I'm
point
going to write.
is, the point is that in my interface, I'm forcing that you should have a navigate function. You should
Yeah.
have this implementation. And I am making it extendable also that currently Uber Ride and Uber Eats is using it. Tomorrow, Uber, Amazon, or any third party, like any other such concrete abstraction can also use it. Yep.
Okay. Yeah. Thank you.
Any other questions? Yeah.
Yeah, so I wanted to ask, like, if two components are interacting, connecting each other,
Mhm.
and the components has various types, then, and if we want to structure it, then only this pattern is coming into picture, right?
Yes, so there are different types of components. So basically, there's Uber Ride, there is Uber Eats, and they have different implementations. Then we use
Impli- co-
implementations like implementation of, say, payment or implementation of navigation.
yeah,
So
it
there are
means two components are connecting, like, so that time this has a relationship is working as a bridge.
Yeah,
connecting,
yeah, correct, correct.
connecting as in you mean Uber Ride and Uber Eats are similar, like that you're saying?
No, Uber.
No, no, the navigation system is getting connected to the actual implementation of the maps. That's what he's saying,
Achha.
I think. So that is acting as a bridge that has a,
Like,
right?
I mean, like Uber systems is connecting with navigation. So
Yes,
this
Correct, correct.
connection,
Yeah.
yeah.
correct. So that is actually the bridge that we are talking about, the hazard.
Hmm. Okay.
Okay, guys, can we, like, this is sort of an easier design pattern, no? There's one good design pattern that I want to cover, and then the next two will be very easy. We can pick up questions more later, but can we go ahead to the interesting design pattern for today? Yes? Yes? Last class of design patterns, guys. I want full energy today. Because after this, we'll be doing like end-to-end system design only. Okay, thank you. Cool. Awesome. Let me just share my screen. Okay, so again, I'm going to tell you a problem and I want you to try solving it yourself. I'll give you a minute to think about it and then let's see how you would solve this. Okay, full attention. Yes, full attention. Everyone. Okay, so we are designing a file structure or a directory structure, basically a file system, call it a file system. Okay, and how does it look? So we have a directory, right? This is a directory. Let me, how do I show directory? Suppose this is the directory, okay? Inside this, there is a file, suppose a txt file. There is an image, okay? Now inside this, we can again have a directory, inside of which we can again have a directory. We can either have a text file, again have an image, or another text file, or another directory. Now inside this, 10 more directories. Inside this, 10 more directories. Inside this text image. So these are different objects that we have to deal with. So how do I design this? Everyone, okay, I can see some answers already in the chat, but I'll give you 2 minutes to think about it. What does it look like? I can see a lot of people saying this looks like a tree. And that is essentially what we are trying to do over here. We are going to represent our objects in a tree. Okay, let's try to understand that why in a tree, what is the problem? See, so this, every parent that we have, now this could be either a file or a directory. Now inside this, again, they can be either a file or a directory. If it is a file, we know that it is sort of a leaf node, that there will be nothing inside this, right? But if it is a directory, then we know that it is going to have something inside, either more directories or more files. Does everyone understand this much? Finally, some DSI we are doing. Yep. Everyone understands? Hierarchical data, I can see people talking about it. Trees. Yes. Okay. Now also, so what do I call this? This can be either a file or a directory. What do I call this? It is either a file or a directory, but it is a common thing. It can be either component, right? No, not just root, even this. This can be either component. It can be file or a directory. Let's just call it a node or a file or a directory, something. Let's just call it a node for now. Okay. So there is a node. Now, either, I guess you all have understood that file and directory both are nodes. Everyone understood this much? That file and directory both are nodes? Yes? Yep. Now both are nodes. So I guess all of you are already thinking about inheritance. That there is one node and then there is a file coming down or a directory coming down from it. Correct? File, or we can say a leaf node. Right? And directory, or we can say a composite node. Why a composite node? Because this guy again can have leaf nodes or composite nodes. Make sense? Does the terminology make sense? Leaf means that, okay, it is the last one. Inside this, it is not going to have anything. Composite means that it can further have more. So basically, what is going to happen is, let me write the official terms. So if we have a component, either it can be a leaf or it can be a composite. Composite meaning what? Composite meaning it has a container. So this file, this directory has what? It is a container. Now container of again components. Why again components? Because a container of either it can be a leaf or it can be another composite. Yes. So this is essentially a container of components. I'm going to repeat, don't worry. So there is a component. I am saying that this leaf is a component. The composite is also a component. Both are components. So basically, file and your directory, both are of the same type. You treat both of them as nodes. But see, your file cannot have anything inside of it. But your directory can have a container. Like for example, we have a list. We have a list of components only, no? Why am I not saying this as list of leaves or list of composite? Why am I not saying it like this? Because again, these components can be either leaf or composite. So see, this is the container. This is the container. Again, it can be a directory or a file or a directory. So that is why a list of further components only, nodes. So again, a list, a container of components, not just of leaves or of component, or not just leaf or just of composite, a leaf of components, container of components. Everyone understands this much? Why container of components? Any doubt till here, container of components? Everyone understands this point? Any doubt? And even if one person is having any trouble, please tell me. This is important. I am quickly going to repeat it also. So I said there is a component, right? So component, basically just say this is a node. Just some random name. It is an interface. Okay. Now who is implementing the interface? File or a directory. File or a directory. Now file is like a leaf node. Why? Because there can be nothing inside the file, right? There can be nothing inside the file. Everyone understands this much? That nothing can be there inside the file. Ankit, Pritija, whoever was asking me to repeat. Everyone understands this much, that nothing can be there inside the file. So this is the leaf node, correct? Now, directory inside can have further components, right? It can either have a file or have another directory or another file or another directory or another file, right? So I'm saying that it has a list. List of what? What is the common type of file and directory? It is the component. So that is why I'm saying list of components. That this component can be either file or directory. Can't we keep two lists? Ash, we are trying to make this generic, maintainable, extensible code, class 1. We are not doing DSA level. We are not doing college stuff. We are doing better things now, maintainable, extensible. Yes, cool. List of components, file directory. Preeti understood? Ankit understood? Yes. Can I go ahead? Everyone understood this much? Okay, so there's a leaf, there is a composite. Composite can have a container of components. Okay. So now both of them are implementing. Like for example, this component is going to have some function, right? That is going to be common. Like for example, in our case, if it is file. So if I have component like this is the interface. So I can have, like in our case, if it is node, I can have something like say get size, or I can have say get date modified. Remember in like if you open Windows there, or even in Mac, you can see size, right, of the structure of a folder. So you can see the size of both leaf and the composite. You can see the size of both the file and the folder. Similarly, you can see the date modified of file or the folder. Yes. Yep. So there are some common functions. Now someone is saying, why can't we just have a one particular flag that is file or is directory? The point is that we are making it extensible. How are we making it extensible? That today there is just file and there is this, but what if tomorrow we have another type, right? So we want to make it extensible. Yep. Okay. So here basically there are going to be some common execute functions. Execute can be what? In our case, execute can be say get size or get date modified. These are the common methods that are going to be there for every file and for every folder. So sorry. So here, get size and get date modified is going to be there for every file and for every folder. Make sense? Yes. So the execute function is common. It is going to be there in both leaf and in composite, right? But if you think of composite, no, if you think of it like list of components. So if you see execute, this guy is actually going to execute. So if I have say get size, the file will actually return that there is like what is the size, or get date modified, that okay, what is the date modified of this? Versus if it's a folder, versus if it's a component, we'll have to go through all the children, right? Like what is this? Like for example, there is a folder. If this is the folder and I have to get the size of this particular folder, I have to get the size of this folder. I will have to check what is the size of this, plus size of this, plus size of this, plus size of this, plus size of this. Make sense? So I'll have to go through all of them and actually calculate the size. Or I'll have to check when was this modified, when was this modified, when was this modified, when was this modified. So was the last one who was modified. This is just an example. To get the size, I'll have to calculate the size of all the children. Yep. Yep. So now what is going to happen is, so basically it has list of components. Let's call it children. Let's call it children. So in this execute now, it is actually not going to execute. What it is going to do is it is going to delegate the work to the child components. So basically it is going to say like for this list, like within this list, get size of all of them and add them. Yep. Yes, exactly. We are doing it recursively. So in the composite one, there is not actually like that is not where we stop. We have to go to all the children and we have to get the sizes. Make sense? What else will we have inside this in the composite? I'm just showing you for an example. So we'll have, say, like add child, or say we will have remove child, or we will have, say, get children. So basically add child means what? Add a file or a directory. Remove child means what? Remove a file or a directory from inside this directory. Get children means what? Get all the components that are there inside. Yeah, make sense? So here there are some common operations. Here is where we are actually doing the operation, the basic element of the tree, right? They are the one who are actually doing the real work. They are doing the real work. Versus in composite, there's a list of components, and then we have like children, and we in the execute, we are actually executing. Now there's an interesting point that I think you must be thinking. We have a list of components. So composite has a list of components. Composite has a component. So there's another relationship over here. Can you tell me what is the relationship? How will the relationship look? List of components inside composite. Composite has a list of components. It is not necessarily composition. It can be aggregation also. I can see a lot of people saying composition. The point is has a relationship. That composite has list of components, right? So aggregation. So again, this is another example where we have both is a and has a. Where else did we do is a and has a? Where else did we do is a and has a? Decorator. Yep. So this is another example of is a and has a. Make sense? More or less? Let's look at one more example and we'll look at the code of that. So we have employees, right? We have employees. Now employee can be, so we can have departments of employees and we can have teams of employees, right? So now when we have, now inside teams, there are again employees. Inside departments, again, there are employees. So one employee is basically your leave, and this team or department is basically your composite. So what is going to happen is when you say that get salary of the department, you're going to go to every employee and get salary and then add it up. Or promote the entire department. What you're doing, you're going to every employee and promoting it. Make sense? Let's look at the code. Everyone with me? Cool. Guys, when you're more active on chat, no, I know that you guys are over here listening, so please try to be more active on chat. Okay. So which one are we doing? We're doing composite, right? So I've written the code for both employee and the directory one. Let's look at the employee code first. So this is the employee component. So what is the employee component? The employee component is the base class, right? Now it has two abstract methods, display info and calculate salary. So both the components will have to have display info and calculate salary, right? So if you see over here, employee component, both will have display info and calculate salary. So my employee, this is the leaf node. So this is the leaf, right? It also has display info and calculate salary. And then department is what? Department is composite. So this also has display info and calculate salary. There is another composite. What is the composite? There is team, right? And now you think of it, that department has teams. Teams has employees. So you again can see the tree structure, right? Employee. Now department has teams. Teams has employees. Again, tree structure. Yep. Make sense? Guys? Yeah, okay. So let's look at how the main looks. So here what have I done is, I have created one employee like Kirti and Amit. There are two employees. Then there is one team sales. Now sales has Kirti and Amit. Then there is one Bob. He is part of marketing. Okay, so two teams now. So there is sales team and there is marketing team. So sales team has two people. Marketing team has one person. Now department or head office has both sales and marketing teams, right? So a tree structure. There are two employees, both are part of sales. There is one employee who is part of marketing team. So there are two teams. There is marketing team and there is sales team. And then there is head office, and head office has both the teams. And now when we do display info and calculate salary, we should be able to see salary of the entire organization, of all the teams and of all the employees. Does it make sense? What I'm trying to do, does it make sense, guys? Let's run the Java code. So if you see over here, everyone just see, focus over here. Department was head office. Now head office has two teams, team sales, team marketing. Now sales has two employees and it has, this team marketing has one employee. See, it gave the total salary. So Kirti has salary 100, Amit has 200, it has 50, and it nicely added all of them. So now see, if on the fly, if Kirti gets promotion and increases the salary from 100 to say 300, okay? If I increase my salary from 100 to 300, I am changing only in one place. You can see the change happening, 550. Yep. People are saying poor Bob. So let's increase his salary also. Let's increase Bob's salary. Let's increase it to say 500. Bob is doing really well. Okay. Here we have increased the salary, you can see. So on the fly, we are able to change, right? And how are we calculating on the fly? Just see over here. So this is the team. And inside this, what am I doing? I am calculating the salary for all. Yep. Here also, what am I doing? I'm calculating the salary for all. I could have taken this calculate salary and put it up like inside my composite. Instead of keeping in both department and teams, I could have had like a common class and I could have kept in common one also. Different ways of writing the code, but you get the point. Yes? Guys? Can you show the UML for this example? I will. Let me show you the code for the other example also. This is the directory structure. Okay, so this is the file system component. Everyone with me? Everyone able to see? Yes, file structure component. So this is the file structure component. It has list contents and get size. So both my file and directory will have to have get size and list contents. Okay. So in my file, list contents is basically I'm showing the file name and there is size. Versus in directory, my list component is what? That I go through the list. So you can see it has a list vector of this, right? Over here also you can see it has a list. So that is why has a relationship. See, it is a word and has a. Why is a? Because it is implementing. Why has a? Because it has a list. So both is a and has a. So two relationships. Just like in decorator. So is a and has a. Right? Let's look at the code more. So this is the directory is a. So this is a. This is has a. Now here you can see in the list contents, I'm essentially having a for loop and I'm going through each of the components. Similarly, in get size, I just have a for loop and I'm calculating the total size. In main, what am I doing? So I have a root. I have two files. I have a directory. I have another file. I have added it to the directory. I have added some files. So basically, you can see a lot of things happening. And then I can calculate the size. Let's run the C++ code for this. So here you can see that directory is root. Then I added document and image, right? So document is there, image is there, then there is subdirectory, and inside that there is data.csv, and then we calculate the total. So total was how much? If we calculate 100 plus 200 plus 150, how much was it? 450. You can see over here. Now, what if I decide to add another one? So I just have this. I add another one. So I add 54, and I am saying data 2, and I am saying it is a big 5 of 500 KB. Okay, let's try to run this. So here you can see there's a directory root, file this. What did we add? Did not get added. Give me 1 second. So here you can see document, subdirectory, data.csv. I am not printing all of them. Kya? CSV 454. Oh, I have not added it. Sorry. So subdirectory, add component, and I am adding my 54. Okay, so I'm going to add it. I just created it. I did not add it. So now you can see data2.csv, and now it has increased by 500 because I added one with 500. Yep. Make sense? Yep. Let me show you once more Java code also. Okay. So this is the file component. Okay, this is a file component. Now, what are the concrete ones? There is file and there is directory. Both of them should have list contents and get size. So these are my abstract methods. So there is list contents and get size. Inside this also there is list contents and get size. Okay. What am I doing inside this? I just have a for loop. Who is doing the actual work? Who is doing the actual work? The leaf node. The file node is doing the actual work. The file name and the size one, right? And over here in directory structure, created a directory. I've created file system components. So see, it is becoming so much easier for us, right? So it is a tree-like structure and we can add components on the fly, right? So we are composing objects into a tree structure. That is by composite. Composite. So this is the container. So it's a composite of live system components, file system components, right? So here, if you see file system component, we are also implementing the file system component and we also have file system component. So both is a and has a. And we are composing the objects into a tree-like structure to represent part-whole hierarchy. Now, I saw this, someone was asking, why part-whole? Part means that, okay, composite, right? So we have like, there are different parts of that. Whole is what? File is a whole. So there are no parts of that. So you will see part-whole hierarchy or a tree structure, right? So the point is that, see, even if it is a file or a directory, we want to treat both of them as same. We want to be able to calculate the size and see the list of contents. Whether it is an employee or it is a department or a team, I want to treat both of them as same. This is the key point. Remember this, all of you. This is the key point, that when you see this, I am treating my employee and my department and my team. Both of them are coming from employee component. I am treating them as same. Whether it is one employee or it is 10 employees in a team or department, I am treating them as same. I should be able to get their salaries. I should be able to display their info. Chevanti is saying, so there is going to be a loop running inside another loop if the component is again directory. If the component is again directory, yes. So there will be another loop running inside it. So we'll calculate the salary for that and then it will calculate. Yes. Piyush is saying in the code, we are going bottom-up approach. That is creating the subdirectory, then adding the root directory. Yes. Meenakshi is saying department and team have a list of employee components and add member method. Maybe it should be enforced within an intermediate interface to ensure that it always implements or calculates. Yes, I said that, right? That this calculate salary we have in both of them, right? So calculate salary is there. We can have like a common one where we actually have the for loop. We can do like that also. Yep. Can we unmute for questions? Yes, we can. Yes, open to questions.
So in calculate salary, the employee thing, what if an employee is part of two teams?
What if employee is part of two teams?
Yep.
We'll end up calculating 2 times. So that wouldn't work over here. Technically, employee shouldn't be part of two teams.
If he's a manager, he can be, right, handling two teams.
Yes. So we'll have to handle it. Like maybe we can add only once. We'll have to see. But yeah, like that will be a problem over here.
Okay.
So it is like you will be visiting the same node in the tree 2 times. So how do we do in a tree? We have like visited and all of that, right? So I don't want to get into DSA wala details, but you get the point, I guess, if you know about
Yeah,
it.
yeah. Got it.
Yeah, cool.
I can see. In the file storage system, don't we need to add a like parent reference in all the components? Like, uh, now currently we are storing all the child as a list of components. So similarly, don't we need to have a single parent over the for all the file system component?
See, why do you want to do that, first of all?
Like, I mean, if I am designing a file system, so I am in particular folder or something. If I want to go back, so how could I? Like, I mean, I can directly go back to the parent, right, with the parent reference. Otherwise, how will I get to know what is the parent of one particular directory?
See, there
we
are
can do that.
we can. There are different ways. Like in trees, also you must have seen, like, right? Like if you have worked on DSA, like if you have done some DSA, you must have seen that we do store parent ka reference. So
Yeah.
if you want to do that, yes, we can. Any other questions? Guys, by the way, a very big congratulations. We are done with the hardest of the design patterns. 2 very simple design patterns left of the course, and we'll quickly cover them now. But I think the hardest part of the course is done. So all of you give a good pat on the back for making it up till here. Whatever you have missed till now, I want you all to practice over the weekend to ask me a lot of questions. We will do more chit chat after the class. But the point is that most of the hard stuff is now done. Now this is like the fun stuff begins now. So the course is going to get much more fun and interesting from now on. I'll make you think a lot now. Yep. Any other questions in this design pattern? Any other questions? No? Looks good? Okay. Can we go to the next design pattern? It is very easy. All of you are going to go like, huh, we are like champions now. We don't really need to know all of this. Yep. Can we move ahead? More energy. Give me 1 second. Okay. So, since we have been doing so many design patterns, the problem that we are trying to solve like till now in so many design patterns is that a client should not worry about a lot of things. Like like a client should just see what I have to use and should not have to worry about the complexity that is having behind, that is running behind, right? This is something we have been thinking of since day one. Yes, that our client should only worry about what he or she has to use. The client should not worry about anything else. Typical client behavior, yes. I don't want to know any complexities or anything like that. So suppose whatever third party is using, or suppose we have like a library that we have written or whatever is happening, we want to usually do what for our client? We will create a simplified interface, right? We will create a simplified interface, and whatever is happening, we will take care of it. That, okay, there's a lot of complex things happening. But then for a client, we'll just give like, this is the simplified interface. This is like the framework that you can use. The term framework that you guys have been talking about. Yep. This is what we do, right? Everyone, is there any question over here? That we are doing a lot of complex stuffs We have to make our life easy for client. So we'll just make an interface and we will take care of all the complex things, like the nice software engineers that we are. We will do the hard things and we will nicely give a simple interface, simplified interface or a framework to the client, and the client can easily use it. So this interface that we give, yes, we are abstracting out the complexity. Yes, so we don't want our client to worry about how things are happening inside. And this simplified interface that we use is nothing but a facade. So you must have heard this word a lot, facade, that just create a facade, right? Like basically it is sort of a wrapper. Like I don't want to worry about anything else. You just give me this particular interface and I will just worry about this. This is a straightforward thing. I will not worry about anything else. Seemed fancy, but nothing is happening. We just create one interface and we as good software engineers will take care of everything else. So this is just a convenient way to access our subsystem. Now inside this, suppose like our facade is taking care of say 10 subsystems. Suppose there are 10 classes it is calling and it is taking care of the whole thing. Yes? Abstraction is the key for whole pattern. Yes, Atul, you're right. Basically main menu in our object, correct. So our facade internally must be calling, say, suppose 10 more classes or a lot of subsystems, but we don't have to worry about any of that, right? So facade will take care of all of this, and this will be the simplified interface that we are going to use. Sounds good? So we are isolating the code from complexity of a subsystem. So there are a lot of subsystems over there. This is a facade. I know a lot of confusion will come that how is it different from whatever we have done so far. So let's compare it with different design patterns. So if I compare with facade and adapter, what is the difference? In adapter, what do we do? In adapter, there is usually one class that is incompatible with this class. And we just make sure that this becomes compatible. Here, there is not just one class. There are a lot of subsystems. Yes, so there's not just one class. There are a lot of subsystems that are there. This is a new interface for existing objects. Adapter was what? Yes, so there was something, but there was incompatible. And there are a lot of subsystems over here. So everyone understands the difference between facade, adapter? Yes? There's another question that some people will say that it is basically if we do creation inside this, then it will start looking like factory or abstract factory, that I am doing different creations. And that is fine. So if we do different creations inside this, you can say that this is abstract factory, but we are not talking about creation. We are talking about structuring different classes that we want to use. We are not talking about creation. So should not worry about creational design patterns at all. Yep. Another thing you will see that there is singleton, that our facade is singleton. That is okay. I want one class to take all the objects, one instance of the class to take all the objects. So I can make my facade as singleton. Now I guess you can combine multiple design patterns. Yep. Yep, guys. There's a good question. Rama has asked, does facade violate ISP? So I was about to say, so now what will happen is that one disadvantage, okay, some people are asking to repeat, so I'm going to repeat firstly. Everyone understood facade versus adaptive. Everyone understood that it is different from creational design patterns because we are not talking about creational. We are talking about, structuring these classes together. Shivangi is saying no. What part is not clear, Shivangi? What part do you want me to repeat? So facade is nothing, but there are a lot of subsystems happening, and I don't want to care about what is happening inside. How is it different from adapter? Okay. I can see some people asking. So in adapter, what was happening is that there is one class, there is one class. These are not compatible. Like what example we saw, this is expecting data in XML and we have in JSON, or opposite we saw, right? That this is expecting in JSON and we have it in XML. So incompatible, we just add one class and make these two compatible, correct? Now what am I saying is that there are a lot of subsystems. Like for example, we have to do order, right? Now in ordering, there are a lot of things. Like suppose in my Swiggy, I have say order manager. Now order manager has to take care of a lot of things. It has to take care of delivery. It has to take care of food. Like it has to probably talk with say restaurant manager or food manager. It has to talk with delivery manager. It has to update say logger and all of that, right? So order manager is taking care of a lot of things inside. What we are doing is just telling order manager that place the order. So inside it is doing a lot of things for us. But as our client only knows about order manager, right? So order manager is talking to a lot of things inside. There are a lot of subsystems. Understood the difference between adapter and facade? Any confusion between adapter and facade? Isn't it violating SRP and OCP is the good question. So now what happens for that is that a lot of times when you see the UML of the facade, no, you will see something like this. So client uses facade and you will see what? You will see additional or refined facade. So what will happen is that suppose you have one facade who is taking care of a lot of subsystems. So say these are subsystems. So what will we have? We will have say a private link to subsystems. You will see something like this. And you will have something like subsystems operation. That if this is say order manager, we have to say have delivery and food and all of that, right? So subsystems cooperation we will do. But if we don't want to do all of that, if we want to further divide it, we will see take care of only the food part and then we will go ahead and create another facade for delivery. So here there is one option. So it is not necessary that there is only one facade. So what is going to happen is that I have an option of adding optional additional facades. So this is optional, additional facades. So this will basically become has a. So this has more facades. See, very simple stuff. Don't think so much. Just whenever you create one interface and you hide out the complexity, you know, it is a facade. It sounds complex, but think about it. You just want your client to know about one interface and you will take care of the rest, right? And if this facade has to do a lot of things, you further divide into a smaller facade. Yep. Very simple stuff. We are doing nothing, just creating one interface. Looks bigger, follow ISP, make smaller interfaces. Simple. Make sense? Yep. Is it similar to strategy? How? Ankit, how? See, strategy is different algorithms. There are no different algorithms. What is the crux of strategy? Different algorithms. I want to decide runtime. Am I deciding different algorithms? No. I am just hiding out the complexity and giving one interface that use this. I will take care of everything else. I am not saying that these are the different algorithms or different strategies or different ways of running the code. Okay, let me show you the code also. Let me show you the code. Can you all see the code? Nothing, guys. They have just given very fancy terms to all of this. But I am sure once you know the solid principles and design patterns and all of this, it will seem like, just use a facade, just use an adapter, just use a decorator. It will become very easy. And we'll compare all of these design patterns again and again. Okay. So here, see, the example is that my client is saying, let's start the computer. This is all that my client is doing. This everyone can see. My client is saying start computer. This everyone can see. So my client is only worried about starting the computer. Client is not worried about anything else. Make sense? Why will my client worry about how the computer is starting? Start the computer and I want to start using it. Can I get more? Yes? Yes? Okay. Now what is happening is that this computer now, this facade that I've created, inside this, there is one CPU, there is memory, there is GPU, there is disk drive, there is network interface. And this guy is nicely, this is the soldier, this is the facade, this is the one who is hiding the complexity, the one who is taking care of us. This guy is running all of it for us and we don't have to worry about anything. So the client is nicely saying, very lazy client, just saying start the computer. Client has no idea that there are a lot of things inside. There's CPU, memory, GPU, disk drive, network interface. Yep. Now you can see there is CPU, there is memory, there is GPU. All of them are getting enabled. They're getting started and all of that is happening. It is connecting to the network. Someone's asking, how is it different from builder? Builder, we were creating complex objects and similar objects. Like we were building, say, you remember Dell desktop and HP desktop, similar desktops we were creating. We are not creating similar objects. We are just hiding the complexity. Simple thing. Yep. Okay, let me give you the, okay. Give me 1 second. You can unmute and ask questions. You can.
Hello, Kruti. How it is, how solid principles are applied here?
Solid principles. Okay, let's think of it. So SRP, so facade has single responsibility. It is just delegating all of this to further subsystems. It is not doing anything else. It is just delegating to different subsystems. Okay. How are we following OCP? That we could be adding different subsystems. Our client will not have to worry about it. Okay. There is no interface like, okay, there is the interface that we are talking about, computer system facade. And maybe if there are multiple facades that we want to have, in that case, we can talk about ISP, LSP. Currently, I've created one simple facade, right? I don't have an interface and then concrete facades like that. If we have that, then we will end up following ISP, LSP, and DIP also, right? But right now, it is a simple facade. Just think of it as a wrapper, that there is a complexity happening, and this is sort of a wrapper that is there. Now, another question can be, how is it different from decorator? Because decorator is also a wrapper. See, adapter, decorator, facade, proxy, all of these are basically wrappers. You will hear this term being used a lot. You will hear this in daily life, right? Just create a wrapper around it. See, wrapper is created for different uses. Like, for example, why do we create adapter? Adapter is a wrapper. But why are we creating it? We are creating it for making two incompatible things work. Why are we wrapping, like what is decorator? Remember, wrapping like toppings, sauce and cheese and all of that. That is also a wrapper. Why are we using decorator? To add more behavior, right? What is the crux of it? To add behavior runtime. Here, what are we doing? We are just hiding the complexity. We're just hiding out the, we are just abstracting out the complexity. Yes? Guys, questions? No questions? Or are you guys so done that now I don't want to ask any questions?
This is used everywhere, actually.
It is. So if you think about it, like, so if you have seen my Uber, Ola, Swiggy, Zomato, all of these systems now, you will see that I have created, sorry, once. I'm sorry. So over there, you will see I've created order manager, food manager, delivery manager. All of them are nothing but facade. And you will notice that I've created all of them as singleton also. So now you can see how I'm combining creation and structural design pattern. I am creating one single instance of facade and I'm making sure that is used everywhere. So that instance will be the one that will be responsible for ordering, for food or for delivery, right? So that I am just telling that guy that you do the delivery. How it is doing delivery inside? It is talking to delivery partners. It is assigning the delivery partners. It has a strategy pattern to assign delivery partners. All of that is happening inside. But as a client, I am just talking to order manager. Make sense?
Kirti, so this pattern is much like template, but we are not forcing any abstract members to implement.
Yeah.
Okay.
Kirti, see, my understanding is, see, any behavior pattern will have a structure, right? As like template also has a structure, we have created one class, one method, and it has a sequence of methods which are getting executed. So inherently, a behavior would have a structure, right? Which is
The
looking,
question
see,
is, what is the difference between behavioral and structural?
no, so I can understand it. I cannot put it into words. I'm just trying to phrase it. So any behavior pattern will have a structure, right? So like template looks like a facade. It has a facade structure inherently, correct? But in template, the behavior is changing because the methods which we have, the nested methods which we have, their behavior is left for implementation onto the to the client, right? Right. So hence it is a behavior pattern. Whereas in structure, I'm just saying that I have like facade, wherein I am saying that I will be calling internal methods, but I'm not changing their behavior. So
Correct.
that is why it is just a structure.
Yes. How you are connecting the
Structure.
class,
So
structuring.
so behavior seems inherently to have a structure in it. So it looks like a facade pattern. So template is implementing kind of a facade structure.
That is why I also said that you will get confused with factory or abstract factory. That is also structure. We are just abstracting out the creation. But for every design pattern, we have to just understand the intent.
Intent. Yeah.
Intent is the main thing we have to understand. After understanding all the design patterns, it will be very easy to implement them. On most of them, we are just having one. We have interface. We are just dividing it. We are making sure we are following solid principles, right? We are making it maintainable, extensible. Same thing we are doing. But what is the intent of every design pattern? When you say facade, what is the intent? Abstract out the complexity. Give me one interface.
Also that I'm not changing its behavior of the internal methods which we are calling, right? So that is why it is only structural.
Yeah.
Oh, okay, thanks.
Kirti, can we assume that whichever class or interface that the client is interacting with can be called as a facade in all the design patterns?
If it is a simplified version and we do not know what is happening inside, like suppose I'm just saying start computer or just create or just do something, you can sort of call it facade. Yes. Okay, I guess more or less everyone has understood. So can we just quickly cover the last design pattern? This is also very easy. Simple stuff only. I'm sure you guys will be able to understand very quickly. Then we'll quickly do a revision of all the design patterns. We will compare all of them. And finally, we'll be done with our design patterns. Last one to go. Cool? Yep. Last one to go, guys. This is the easiest. So glad that so many people have showed up. See, till now, if you have showed up for the classes, no, like if you have done design patterns, all of them, the next will be the thing, like designing end-to-end design patterns will be so interesting. We'll actually talk about real examples like IRCTC, recommendation system, all that is going to be really fun, right? We will apply all the design patterns and all of this. So if you have attended till now, at least all of you should continue attending for the next 2 weeks. No, none of you should miss any classes because especially the end-to-end designs, know how the discussion is going to be live. It is not going to be like that in recording. Live discussion is just different, right? Because you're attending live, you are able to ask me in the chat and everything. So try to attend the next 2 weeks as well live. Okay, cool. Enough chit chat. Moving on to the last design pattern. Everyone excited? Yes. Throwback to our college days. I am sure like some of you are still in college, but throwback to our college days. Remember when you did not want to show up in classes, you would say your friend that give a proxy for me. Yes, give a proxy for me. So proxy attendance, yes. So basically you're saying that someone else should show up in place of you or on behalf of you. That is nothing but proxy. For the HLD people who have already attended the HLD course, you remember proxy, we did the same thing, reverse proxy, forward proxy, similar thing on LLD level. Here, we basically have a handler or a wrapper of a class, or you will hear the term surrogate also. Handler, wrapper, surrogate, you will hear all of this. Yes, just what are we doing? It is the same interface, but we are just hiding it from our client. Now, what is the point of a proxy? Why do we need a proxy? Can you guess? Why do we need a proxy? Why do we need a proxy? That is my question. Why would we need a wrapper or a surrogate or a handler? So I can see some people talking about security, about encryption. For 75% attendance, for testing, the object can't be created, middleware, abstraction. See, the thing is that proxy is used for a lot of use cases. By the way, for those who did not attend HLD, it is fine. Like, this is nothing related to HLD. Just focus over here. I was just giving an example because they've attended. Okay. Over here, see, there are different reasons why you would want to create a proxy. And based on that, it is called types, but it is essentially the same thing. Like, the reason why you would create a proxy is a lot. Like, for example, remote proxy. Now, what does a remote proxy means? That there is somewhere else where you want to send the request. There's some other object where you want to send the request. But suppose you want to encode it, or you want to say, send the encoded request or the arguments in a different way, in a different address to a different object. Basically, you want to call another function in a remote place. So going to call it remote proxy. Remote proxy. Yes. Just nothing I am doing. I am calling it over here. And then I am calling another function somewhere else. Okay. For example, DB. Whenever you talk about DB, so suppose there is DB over here, and you have, say, a DB instance ka object, right? You're doing the same thing, whatever you would do with DB, but you are not actually talking to DB, right? You're talking to DB instance. So you will hear this term being used. So this object is basically a proxy for your database. Yep. So basically, instead of talking to DB, you're talking to who? You're talking to another instance, your DB instance. Yes. Now, what is another case? Suppose virtual proxy. Virtual proxy is what? Now this is interesting, guys. This is interesting. Listen to me very carefully. Like, for example, I want to work on a file. Right now, I said file.open. And I just gave my proxy that, you know what, open this file and keep. Right now, I am not using it. Okay. Maybe after some time, some time later, I started using it. So this proxy, what it did was, it did not open at that time. Proxy is smart. What it did was, it stored the file name somewhere. And when you said use, only then it opened the file. So basically what proxy is doing is, proxy is doing lazy loading for us. You remember this we had discussed in Singleton, lazy initialization, that we are not going to initialize it right now. We are going to initialize it later when we need to use it. Remember we had talked about lazy initialization? Yes. So what this virtual proxy is going to do is that it is going to say that, I will open, it will store the file name, but it is smart. It is making things what? It is making things more efficient for us. It is not opening the DB instance, or it is not actually doing stuff until you actually need it. When you start using it, it will use it. Yes, Vasant, Yagni, you aren't going to need it. Yep. Cool. There's another, see, these are just fancy names, but you understand, right? That why should I create it until I need it? Then this is just, I am just passing it to this particular instance for what it is. I am passing it to this guy, but then it is the one that is going to call another object. Simple stuff only. Just adding another layer of proxy in between. Adding another one. Suppose there is protection proxy. I could see a lot of you were talking about security. So when you want to access, suppose a document, and a person has passed the user name or something like that, what we will do is we will check the access level, that can the user access the document or not. If the user can, then it will actually go to the document and use it. So this protection proxy is what? It is a document proxy, that you are passing the name, and then this guy is checking that what is the access level. So it is checking for the access permissions for the, like, whatever request you are having, say open the document, or say on Netflix access a particular video. Are you 18 plus to be able to access this particular video? Something like that. Rama is saying, doesn't it look like a family of different behaviors? Rama, these are just types. These are different reasons why you would add a proxy. What you will be doing in the end is the same thing, but either you could be doing, say, lazy loading, or you could be checking for, you could be checking the permissions, or you could be just calling another function. These are just different reasons of having a proxy. There's a very good example. This is for C++ people. There's something called smart proxy. So I guess this everyone knows that in C++ you have to do new and delete, right? You've seen so much of C++ code. So you do new and then you delete, correct? So what you do, if you have seen, there's a video with Amit on my YouTube channel where I've created the video on smart pointers. So what have we done on that? If you see the implementation of smart pointers, no? So smart pointers is nothing but a wrapper on pointers, and then we nicely do the deletion. We take care of the deletion. Smart pointers, C++ people might have used. So if you use smart pointers, you don't have to worry about new and delete. You just use smart pointers how you would use pointers in general. How you would use pointers in general, you can use it like that. Yep, so smart pointers is a good example. Yep. PK is saying to take money, no need for bank. You can take money from ATM. ATM is the proxy. Yes, ATM is the proxy. Even check is a proxy. You don't have the cash. It's a proxy, right? Now, how is it different from adapter? I can see this confusion happening. Adapter was for different interface, right? We were trying to for incompatibility. Here it is the same interface. See, our client could have talked to this target guy, could have talked to this. We are just adding a proxy in between. We could have talked to the guy directly. We are adding it for something extra. Maybe we are decoding it. We are checking for permissions. We are adding a wrapper, smart pointers. So it's just a proxy. Let me share the code also. So, all these terms that people use, like just add a facade, add an adapter, add a decorator, add a proxy. Now you guys know these terms. Now you'll be able to understand what these people are meaning, right? Okay, let's look at the code. Everyone is able to see the code? Yep. So we are in Facade. We want to see proxy. This is the C++ code. So here what I've done is I've done the lazy loading thing. So in my image, I have an image proxy. So this was my proxy. Image is high resolution image. So I don't want to open it right now. Until I display it, I'm not going to open it. Okay, so if I do display, what I'm going to do is that when I display, so if you see in this, when I get image proxy, I am not opening at that time. So if you see over here, I just created it. But here is when I'm actually creating, like I have just saved the file name over here. Here is when I'm actually creating the real image. So this is the real image. and it has display and it has load from disk and all of that. See, it is not like my main couldn't have talked to the real image. It could have talked to the real image, and both of them are coming from image only. So there is an interface. So both of them are coming from the same type. So both of them are of the same type. So there is image, there is real image, and there is image proxy. So if I do something like, say, image equal to, so something like image equal, okay, for Java people, let me not use this. So if you do this, and let me write in Java so that everyone can understand. Let me go to Java. So here if I did, oh, so I have actually done that. So here you can see image proxy. So image is the base type, right? So here you can see this is the base type, the interface type. And here you can see the image proxy is there, right? Now in image proxy, you can see it is implementing image. Both of them are from the same type. The real image also, the image proxy also. Let me show you the UML quickly, then we will come back to the code. Give me 1 second. Let me show you the UML. Can you all see my screen? Can you all see my screen? Yes? So our client is doing what? Client is essentially using the interface, right? The interface was what? It was image. Now it will have a bunch of operations. Again, the methods, the abstract methods. Say in our case, it was display, it was load image and all of that. So it will have operation 1, operation 2, operation 3 and all of that. So there is interface. And then there is a proxy. So proxy is there, and then there is the real service. Real service is what? This was the real image. So if you notice, my proxy will have the real service. So what relationship is this? Proxy has real service means what? So my proxy should have the real thing, no? Should be able to deal with it. So like you're dealing with that. So yes, aggregation. So client is talking to interface. Client doesn't know that you're talking to proxy or to real service. It is nicely talking to interface and it feels like it is talking to the real service. But in reality, it's talking to proxy, which has the real service. So client doesn't come to know. Yep. Yes, aggregation as the life cycle is independent, correct. Let me share the code again. So UML is clear, right? UML is clear, guys. Let's look at the code again. Okay. Java code, please. Okay. So this is the interface image. This is the real image. This is where the actual display and load from disk is happening. And this is the proxy. So see, proxy has the real image. So proxy has the real service. So aggregation, right? Here, so in my main now, when I create the image proxy, what am I doing? I am just nicely just saving the file name. I am not actually created the image. The image is null only. So what am I doing? I'm doing lazy loading. How am I doing lazy loading? When display is called, only when display is called, I come and see, oh, it is null, I will create it. If it is not null, I will just display the real image.display. What is happening in real image.display? I am actually displaying the image and I'm actually loading it. Make sense? Okay, I'm going to let you ask questions. Any questions?
Yeah,
Keith,
one question, Kirti. You said that client is talking to the interface, but in this case, client talks to the proxy, no?
So it is talking to the interface, how you're creating it. So the proxy that you are coming to know, but the type in later is image. So this is the type, right? Image. Only while creation, yeah.
Is there any difference between a proxy and interface? Like someone has given the example of ATM. ATM also acts as an interface and proxy as well.
So there is an interface, but see, the point is if you make the proxy as the interface, see, your proxy should have your real image, right? and both of them should be of the same type, and that is why you have the image. Both of them should have display, so that you can display like this. See, when you do not know actually that you're talking to proxy or you're talking to the real image. So you will just do display, right? That is why you need the interface, and from interface you have the real image and the image proxy.
Okay, got it. Thank you.
Kirti, if when you're doing implementation for protection proxy, then in that case, it will not remain same. In that case,
You
you
would
will
have
have
to pass like user name or user level or something like that. While
or you have to add one more function into your proxy, which can be which will be method added to your proxy, which will be first checked, validated, and then it will go to the real server.
but that will be like a private method.
Private method, yeah, yes.
Correct.
So every will have a different remote proxy. I'll give you an example. I don't know the code, but I know the business use case. So when I'm making an object which I need to send over the network, so what I do, I create a object, let all the data come to it, get all the data filled into that object, and only then make a call over the network and send it across. So I don't have to do a lot of IO operations every time. So I wait for it to get completed. So maybe your transaction management will also use a proxy internally. No, it will wait for all the transactions to get completed. And then when I'm committing it to DB, so in between it is acting like a proxy.
Yeah,
And only
yeah.
then I make a final call to my place where I need to go and store it.
So to the client, it is looking like you're actually sending it. But what
Yes.
you're doing is there's a proxy who's actually keeping all of this information till you get all the information, and then it is sending later.
So like in DB, a lot of people will be using SQL, right? There you always put a command and then finally you say commit. Right. So there's an instance being created of an object, proxy object is created, where all the commands results are stored, and finally they are committed to a DB. So there's acting like a proxy in between.
Yeah. So we'll see the proxy word getting used in a lot of places, right? That is why don't get confused. It can be for different uses. That is why I said remote, virtual, protection, smart. There are different uses of the proxies. The UML is going to be the same. The logic is the same. That you have an interface. I guess this much everyone can think now, right? That there is an interface. You want to follow ISP, have as small interfaces as possible. So this is the real service, right? And then you want to access proxy. So both of them should have same type. So you created an interface. Just think, if you were solving this, how would you do it? You want to be able to use proxy instead of the image. So both of them should have the same type. What will be the type? It will be the interface. Any other questions?
So is there any difference between API gateway and proxy? Like it also handle as a traffic. Suppose everything coming to the proxy first, then it
So
move
if
on
you
the.
think about high-level system design, then yes, load balancers, API gateways, all of those are proxies. So in HLD, we had discussed a reverse proxy, forward proxy, but similar to how observer design pattern is like PubSub in HLD, right? If you compare like that, observer design pattern is what? It is between objects and classes in a smaller level. Similarly, proxy design pattern is at a smaller level. We are talking about objects and classes. If you think about high-level system design, you'll be able to think of API gateway, load balancers, and all of that. We are talking about low-level system design. So we have to focus on objects and components.
Kirti, so we can say that our system cache is kind of proxy. So
Yes.
we're writing.
Yes.
Thanks.
Kirti, if you want to integrate a payment system, but before that we want to do a mock payment system, gateway payment system. So in that case, even that is a proxy, right?
Yes.
Actually, here proxy pattern is not doing abstraction. It is just hiding the other classes, right? This is just a wrapper, means it is not abstraction like Facade.
No, it is abstraction, right? So it depends upon the use case, but yeah, it is abstraction as well.
But
we are abstract, like we are abstracting out that there is a proxy or there's something happening in between. You can think of it like that.
Oh, is it we can call PhonePe and Google Pay as a proxy for banking API?
I think in the end you do use Google Pay, Paytm, right? Like, but yeah, they do some extra checks, so you can say that there is a proxy added over there.
Yeah, internally, like we have same 1 lakh, right? We can use, right? One day. Suppose we can use from Google or from Paytm, both we as a combined we can use as a 1 lakh, right? So internally they are calling banking. So overall it's interface or proxy we can say.
So overall, what Google Pay and Paytm might be using is an adapter pattern, right? So the information that Google Pay and Paytm, they are a whole, I mean, you're talking about systems as a proxy.
That's what, like, try to talk about object level over here, right? Like, what is the exact object? Are the objects incompatible? Then it is adapter, right? Are you adding something extra in between? Are you, say, doing lazy loading or checking some user access and all of that? Then it is what? Then it is proxy.
Okay, sure.
Yep. Guys, we'll do a quick revision. But before the quick revision, I can see a lot of people leaving already. Can we take a quick small video/photo? Because the end of the design patterns before we do a quick revision. It's the end of 3 weeks. I guess I want to see the faces now, please. Yep. Can you all turn on your videos? No, too much to ask for, Kya? After this, you won't have to hear my voice or see my face for next 4 days.
Ma'am, you blocked us, right? While trying to open.
Oh, okay. Let me give it. Given. Someone is saying, why do you ask for a video at 11 o'clock? Most of us are not even presentable. Even I am not presentable. I just sit like this and teach. So we are all learning. We are not supposed to look presentable. We should look like we are working very hard. We are, we just care about studying. We don't care about looks. It should look like that. So how do you guys feel done with the design patterns, ready for end-to-end systems?
We are feeling like we will be in product-based company soon.
But now, now LLD will be very easy for you guys. Now it will be like super easy, done with design patterns. Yes, guys, some more, like a bit more energy. Come on. Really proud of you all for showing up for 3 weeks. So thank you so much. Yep. Good. Yes, thank you for that. There are more people coming online. I will take the video from the Zoom screenshot, but thank you so much. Let's quickly revise all the design patterns before we get to the next class. Oh, by the way, okay, quick homework for the weekend. You will be working on the hackathon, right? You will be doing that. But there are 3 systems that we are doing next week, right? It is present in the curriculum. So I want you all to start thinking about them. Like we are discussing IRCTC. So what will be the objects? What are the possible design patterns you can use? And write them down and share on Discord. Like it will literally take 10-15 minutes. Just sit with your phone, type it down, that what are the possible design patterns, what are the possible use cases in these systems. And I will actually accommodate that in my design and I will try to design accordingly and we'll discuss it in the classes live. Okay?
One quick question, right? So generally, there are 2 types of design questions or interviews. One wherein we are given the PRDs, one wherein we have to design the PRDs. So we'll
talk about system requirements. We'll talk about how to, tackle it in the interviews. We'll do all of that.
No, my question is, will you give the PRD for IRCTC like you give for calculator, or will have to come up with the PRD by ourselves?
You have to come up with yours.
All right.
And also, Kirti, in this assignment next week, which is starting, you will go through from BRD to SRS and SRS to high-level design and high-level design to then low-level design. Is it a complete cycle?
We'll be talking only about low-level system design.
Okay, that's fine.
Yeah. We'll be talking only about low-level system design.
Okay, but then we will do BRD followed by the SRS. Is that the case? And then the low-level design. Is that the case?
What is the full form of BRD?
business requirement document more from the business point of view, and SRS is system requirement specification more from the system point of view.
So we'll do system requirements. Like we will see, like we will note down the requirements in general, and then we'll see how to drill down to the requirements that we are worried about when writing the code.
Okay, so you mean the top level of the requirement will still be from the business point of view, but we'll drill it down to the lowest level and eventually get into the system level requirement. Is that what you're saying?
Yes, yes. And we
Okay,
will discuss it also, how to do it. Like, so especially like a lot of people are over here for low level system design interview prep, right? So we will talk about what are the different ways to tackle that. Okay, if this is the system that is given to you, because if you see some systems, if you see like a system like chess, right? Chess or tic-tac-toe, like you don't have to ask so much about the requirements, right? You know that what is chess, what is tic-tac-toe. But say you are asked to design something like IRCTC or Swiggy or Zomato, then this is what? This is basically broader systems, and these are very narrow systems. So we'll also talk about if there are systems like chess, how much time you should spend in, say, asking the requirements and all that in the interview, versus if you're designing something like IRCTC Swiggy, how much time do you invest in asking the requirements? The goal of low-level system design requirement and low-level system design in general is that we should be able to write code. We should be able to write running code. Okay, so that is the main thing. And the hackathon that is given to you, again, I want running code. I want you to be able to show to me that you have implemented these design patterns. So now you're completely ready for hackathon. As
But
we
the-
do the different
but-
systems also. Yeah.
Sorry. Yeah, but then quick question is, like, you're comparing the chess with IRCTC. Like chess is like one system or maybe one component or maybe one system, if I say. But IRCT is like a system of subsystems.
That is what I'm saying. So that is like a very narrowed down system, right? It is very easy to design that. So you don't have to spend so much time on the requirements. Versus if it is IRCTC, Swiggy, Amazon, you have to ask your interview, you have to drill down to the exact module or the component that you're going to be designing. Right? So you have to communicate, you have to ask, okay, this. You obviously cannot take care of everything from, say, logging to authentication to everything, right? So we'll drill down, like for Amazon, what is the core logic that you want me to code? And then you will say that, okay, I can do this. And in the end, for any system, you should be able to write some demoable code, some running code. Probably you can use 2 or 3 design patterns, and you can show that, okay, this sub part or this is small part of the system is running.
So Kirti, I'm still going through the high level design, like as I discussed with you other day. I'm going through the video recordings and everything other day. I have not reached to a point where you talked about microservices and APIs, but should there be a use case or should there be a requirement where one has to authenticate himself or herself as a TPT, maybe third party user, or as a internal user of the company, or a external user or external staff? Like it can be different cases, right? I can be a third party user, I can be internal user. So those kind of sequence flow, those things will be covered in the high level design, or will that be covered in the low level design?
Right. See, the thing is that high level, see, when we make a system like Amazon, first we talk about the high level system design, right? And then we say, okay, now we'll be making the small microservice or the small components or the monolith. Then we start writing the code. So when we start writing the code, that is low level system design. Guys, I can't stop reading the chat. Can you guys stop, please? Yeah, Jelly Bean is my proxy, by the way. Yep. Okay, guys, can we do a quick revision?
Yeah, so Kirti, just to complete the statement, how all the components are integrating with each other. For example, there is a user making a request to API gateway, to authentication server, to back to micro.
Sir, again, please do watch the high level system design videos first. Then we'll do discussion, right?
Yeah, that's what I said.
This is not right to do the high level system design discussion in the low level system design, right?
No, understand. That's what I said. I have not reached to a point where you're talking about microservices APIs, but if you have already covered this sequence flow and everything over there, that's fine.
Everything.
Okay, thank you. Yeah.
Okay, guys, quick revision we will do. We'll start from design patterns. What are the 3 types of design patterns that we did? Okay, should I take names or will you guys be like 10 minutes of energy, guys? Then we'll go. I'll let you go. What is the first type? You can unmute yourself. Creational. What was the other type?
Behavioral.
Behavioral.
Structural. And structural.
Structural.
In let's just start from creational. What was the first creational that we did?
Factory.
Factory.
Simple factory. When do we use what? When do we use simple factory? What is the use of it? Guys, create.
Runtime if we want to decide which class object we want to create.
So you want to
Encapsulating the implementation of
creation.
creation.
So we don't
Into
want to
another
know how the creation is happening. The simple factory will do the creation for us. Yes. Create similar type of objects. Remember?
Hmm.
Okay. What was the next one that we did?
Abstract factor.
Factory method.
Factory method.
When do we use factory method? Factory method. Guys, quickly, come on. I will also tell you what are the important ones for interviews and also quickly tell me what is the point of factory method? Subclasses can make changes. Yes. So you want to let this subclass. Please mute yourself if you are not talking. Please mute yourself if you are not talking. I can hear a lot of disturbance, but I can't hear anyone answering the questions.
If object creation logic is complex, then we can go for factory method, like
Yes.
where we implement, where we provide an interface for all the different types of factories.
Yep.
And then we provide concrete factories, and then where we provide the object creation logic.
Correct. Very good. Thank you.
The right word would be if the object creation methods are different, not complex, right? I mean,
Yes, so each subclass should, like we need more customization. So each subclass basically has its own factory. So there is more customization than a simple factory.
Yep, you are letting the subclasses only do the creation. The factory is not doing the creation. These subclasses are actually doing the creation. Yep, there are concrete factories. Then what is the next one that we did?
Abstract factory.
Abstract factory.
When do we use abstract factory?
When you have similar class of objects.
Family of
Family of factory.
Family of factories.
Family of factories. I guess this is clear, right? Yep. After this, what did we do?
Builder.
Prototype.
Okay. When do we use builder?
When there are complex steps involved in creation of object.
Okay.
Step by step, we create object. Yeah.
when your different objects have similar creation methodologies, but those methodologies might, I mean, the internal specifics of methodologies or the values might differ.
Very good. I really like how you answered, Tanmay, very to the point. Who is the one who actually says that you have to run these steps and then these steps?
Director.
Very good. Yep. After builder, what did we do?
Prototype.
Singleton.
We will discuss all of them. I don't remember the order in which we did. I think we did prototype. What did we do in prototype?
After this prototype.
When we want a copy of one object, we can use prototype.
So anything else that I should know in prototype? Copy of object, what else?
We make deep copy of objects.
Deep copy of objects. Okay, what else? Cloning, yes.
Yeah, cloning. Clone method is provided.
What is the next one that we did after prototype?
Singleton.
Singleton.
Observer.
When do we use singleton?
When we need only one instance.
Only one
instance
object.
of object. Yep.
Threads.
This we will use a lot. Among these, see till now, I would say simple factory is extremely important. Singleton is extremely important. Like mark them this for interviews perspective. Next.
Observer.
But observer is behavioral, isn't it?
Are we done with creation?
Yes.
Yeah. Okay. So what is the next one that we did?
Observer.
Observer.
What do we do in observer?
When we
make the changes depending on reflection in one parameter.
Yes. So whenever there is a change that is happening in state of one, like the subject, we want to do some, or we want to update or take some action in all the observers. Yes?
Yeah, broadcasting of message.
Broadcasting, yes. What is the
In
next one?
register and unregister observers.
Yes. So what are the
Next
three main functions that are there in observer? Add,
register, deregister, notify.
yes, register, deregister, notify. And there's a list of observers inside the subject, right? So has a relationship. We talked about all of that, right? After observer, what is the one that we did?
Command design pattern.
Command design pattern. Then what do we use command design pattern for?
When you take the command as an object so that you can undo and
Encapsulate command or request as an object.
Yes. Yep. Very good. So what were the different classes involved? What are the different, like?
We had
Invoker.
invoker,
receiver,
and then receiver.
Yep. So invoker, receiver, command interface, concrete commands. Yep.
Yeah.
Okay. After that, what is the next one that we
chain
did?
of responsibility.
Chain of
responsibility.
When do we use chain of responsibility?
When we want to.
And we wanted to know the next handler dynamically based on some conditions.
Yep. We need a chain like this, that this guy will decide who is the next person who will fulfill the request. Do we need a next person, or is it done? Like done, stop over here, or who is the next person who will fulfill the request? Chain of responsibility. What are the major components in chain of responsibility?
Handler.
And each handler has what?
Yeah.
Next handler.
Next handler.
Successor.
Yeah. Next handler or successor. Yes. So everyone remembers this, right? The main point is to know the crux, the intent of each design pattern. That is the main point. Even if you forget the exact components, it is fine. It will come to you with practice and all of that. You should understand the intent of every single design pattern. After chain of responsibility, what was the next one we did?
Iterator design pattern.
What is it used for?
To access the elements.
Next element. And
It's used to iterate the complex objects or user-defined objects.
Also in aggregate of objects, which might be a list.
Yeah, actually traverse the aggregate of objects. So we have aggregate of objects, and if you want to traverse it based on rating, based on some filter criteria.
to abstract a data structure without knowing the inside working.
Like you want to be able to traverse, as a lot of you already said, traverse through the aggregator. Yep, very good. What is the next one that we did after iterator?
Strategy. Oh,
No, there is the template design pattern. Oh, sorry, no, strategy. Yeah, correct.
strategy.
Strategy, there is.
Is strategy behavioral only?
Yes.
Yes.
Yes. Strategy, then
Runtime algorithm.
What do we do in strategy?
When we want to decide from a family of algorithms,
Runtime.
Algorithm.
then we use the strategy pattern.
Yep. So what are the main components? There is one
Strategy interface, its implementation for different algorithms.
Yeah. So there is
context,
concrete strategies. We also talked about how we can merge it with, say, creational design patterns to create the strategy, right?
Correct.
Yep. Okay. After strategy, what did we do?
Template design pattern.
Is template behavioral or structural?
Behavioral.
Are you sure? Behavioral?
Yes.
Yeah.
Yes.
Yeah.
What happens in template?
When we want to set
Yes,
the
a skeleton of
We define the steps actually and give the implementation of the steps to each of the individual components.
Yes, blueprint, or we can say skeleton of steps.
Yep. So a lot of you already answered. So skeleton of steps, and we want to force the child or the deriving classes to have these steps, right? So you set a template and you have to, when you force them, that you have to have these steps. And that is why we have like interface and abstract methods. Correct?
Actually, why it is behavioral, I'm still doubt.
Why is it behavioral, guys?
because you're following the steps in the order.
The implementation is runtime. So the behavior is runtime. You are asking the user to define how the behavior would be of the nested methods.
I think they're enforcing a particular behavior. And so that is the reason I think it's behavioral.
The template method is enforced, right?
Actually, that template method is created, and all the concrete class can change this behavior as per their requirement. Only the sequence is fixed.
Correct. Right.
Makes sense?
Yeah.
Yes. Yeah.
I like that you guys are only answering now. I should not have to answer anything. Next 2 weeks, I'm going to do nothing. It is you guys who are going to run the classes. Okay. Structural. What is the next first one that we did?
Adapter.
Adapter.
Why do we need adapter? How do we use it?
For
When-
incompatible.
Two incompatible classes.
After adapter, what is the next one?
Bridge.
Decorator.
Oh, sorry, decorator.
Decorator.
Okay. In adapter, by the way, what are the main components?
Adaptive.
Adapter and adaptee.
And then there we talked about class and
adapter, object adapter.
Yeah.
And giving importance to when there is a choice.
Yep. Very good. Very good. Okay. Decorator, what do we do? What are the major components?
Decorator follows both is and has a relationship. So components would be
We have food and get description, get price, that is in the interface. And once we add on, that is we can say it's decorated.
Explain like in general terms, not in terms of example also. Like what is decorator? Like why do we
So
know?
after decoration, we are forming the same object. That's why it's an is also, and it has a also.
So
Item decorator and concrete decorator.
we use decorator pattern whenever we want to wrap a class with a different class, but at the end of the day, we want to return the object of the main class only. So it's generally used for wrapping.
Yep. Vishal is asking, have we done state, interpreter, mediator, visitor, memento, flywheel? See, these are extra design, like these are more design patterns. Now, some of them are common, like state, flywheel, but I think these design patterns are enough, and that is why I added them to curriculum. If I can cover any of these a bit during the next 2 weeks, I will try to. But these are the important ones that were part of the curriculum we have already done. Okay. After decorator, what was the next one?
Bridge.
So what is there in bridge? What are we bridging?
If we want to separate implementation from the abstract, then we can go for bridge.
Yep. So implementation is different, abstraction is different. We're bridging those two between, right? What was the example that we saw?
Uber Eats, Uber Rides, which will use map. Map could be Apple Map or Google Map.
Very good. What was the next example, that next design pattern that we saw after bridge?
Composite.
Composite. What did we do in composite?
So we used a tree-like structure wherein we had a component, we had a leaf node, and we had a composite node. Composite node also had, composite node is a component, but it also has a relationship with the component.
It has a list of components.
List of components. Yep. Very good. Next.
Facade.
Proxy.
Okay, these two we just did. So quickly tell me, why do we need proxy? Why do we need facade?
Facade is for abstracting the subsystems. And
Facade is for abstracting
subsystems.
The client from complexity.
The client from complexity. And proxy is for?
Proxy to the client, it looks like the end object, but it's actually.
Yeah, very good. So as you guys can see, you guys are now the masters. Now let me tell you something in terms of, okay, I'm just quickly muting.
Kirti, what are the important ones in structural?
I will tell. In structural, usually, see, when I'm saying important in terms of interview, first let me tell you my perspective. Why am I saying that these are important? It is not going to happen mostly in interviews, 99.9%. It will never happen that your interviewer will come and say that implement this design pattern and show me. You will be given a problem and you will have to solve it, right? Now, mostly in systems, we will discuss how you would have to drill down to a subsystem. And you will have to say that, okay, we can use this particular design pattern or this particular design pattern. So in interviews, what we have to do is we have to be smart about it. We have to try to talk about the design patterns that will take you very less time to implement and that you can run very fast. For example, builder is something that is very common in, say, real systems. Okay. But if you start writing the code of builder in an interview, there's high chance that you won't be able to finish it in, say, 20-25 minutes. Correct? Make sense? But versus if you see simple factory, observer, strategy, or even adapter, these are very smart choices in an interview. You don't have to just show off your knowledge. You also have to be very smart in an interview and take it like a plus point, that what should you talk about in an interview. For example, you just say that we can probably use builder over here. But if that is the use case, it is okay. Suggest builder, but say because maybe we are out of time, maybe I can implement this part of the system and not this part of the system. Like for example, in my interviews, very frequently, I have implemented simple factory and singleton together, or singleton and strategy together. See, in singleton, if I implement and if I take care of multi-threading and I also talk about lazy initialization, early initialization, my interviewer is going to be impressed. Okay. Versus say if I start implementing chain of responsibility, I might take some more time to talk that, okay, this is the next handler, this is the one that is doing it. So you have to be smart that, okay, this is the use case that is given to me. How much time do I have in the interview to implement?
So basically, like what I got from it is like we have to drill down to a subsystem that takes less time, and then like fit a creation design pattern that fits that. Like basically going to a system where we get to fit a easy design pattern or a less time consuming design pattern. Yeah.
Correct. See, again, I am saying that I am not saying that do only these. That is not my point. Okay. Don't take that I will only learn these 4-5 design patterns and I will go to interview. That is not what I am saying. What I am saying is that in an interview also you have to learn to be smart. Okay. Now you could either write the code for creational or behavioral or structural. You will be doing the structure also, you will be doing the behavior also. But you can be smart and you can say, maybe I will write code for this. Nobody is expecting you to write code for the entire thing in 60 minutes or even in 2 hours. Let it be 45 minutes, 1 hour interview. You have to gather the requirements. You have to write the code. Your code should be running. So you have to be smart about it. What design pattern should I use? What should I even suggest? You can say, see, suppose you are designing something and you can suggest that here I could use builder, here I could use command, here I could use decorator. But since we are out of time, maybe I can implement or I can write the code for this subsystem that requires a simple factory and a singleton, because I think based on the time that I have, I can do it quickly. Very, very likely that your interview is going to say yes. And never go like, okay, another tip that I had given in HLD also, like suppose you suggest that I will be implementing build, that in my system, you have suggested that I can use builder over here, I can use a strategy, I can use simple factory, I can use bridge. Suppose there is some system where you said that I can use this, you suggested. And now nicely you said, I will give the option to the interviewer. And you go like, which out of these should I implement? Your interviewer is very likely to say a hard one, right? The interviewer, obviously, right? The interviewer will be likely to say builder or something, and you might not be like so confident about that design pattern. Instead, always in an interview, be smart and say, I was thinking of going ahead and implementing singleton or simple factory. Is that okay with you? Can I go ahead or should I do something else? If the interviewer is very, very particular that no, I want to see this code only, then your interviewer is going to say that, okay, no, you have to do this part only. This is what I am looking for. But the chances are very high that your interview is going to go like, okay, if this works for you, just show me that code. Whatever design pattern you are most comfortable with, that you can quickly write, try to write that code, right? At least you, like whatever hackathon you are practicing now, whatever systems we do, at least practice some design patterns about which you're very confident. Like over there, you should not have to think about that, oh, what was my interface, what was my concrete, what was happening, I don't know about this, right? You might get confused with it. Instead, be very used to writing some design patterns. Like singleton is one very simple: get instance, take care of multi-threading, your interview is going to be impressed. Observer, very simple, 3 methods are there: register, unregister, notify. Strategy, very simple, create strategy. Add another creational design pattern and create strategy and have different algorithms. Very easy to show also, right? And it sounds impressive. Someone said in the chat that I'm very comfortable with Facade and Proxy. Then the interviewer is not going to get so impressed, honestly, right? Because then you've just added a proxy. Then that is not impressive, according to me. Having implemented observer, strategy, or a good design pattern is impressive. You talk about adapter, impressive. Talk about decorator, impressive. Think in terms of an interviewer. What would impress you if you were the interviewer? And if someone talked about a particular design pattern and was able to write code, what would be impressive for you? Think in terms of it, like think from the perspective of an interviewer. Make sense? Enough pep talk, yeah? Now I will let you guys go. Use this time, use the weekend to think, to come up with possible solutions. And please, over the weekend, don't just work on hackathon. Practice, participate in all the quizzes. Intentionally, I have made some quizzes very confusing. Participate, ask questions that why is the answer to this quiz this. Please participate and ask questions, okay? And for IRCTC, for the systems that we are going to be doing, please suggest that these are the possible design patterns. Even I will be writing the design patterns over the weekend. So for a particular system, if you want me to show the code for a particular design pattern, tell me, I will do that. Okay. So you suggest and I will do it accordingly. So this is a live course and it can be really, really useful. So you have done so far. I really want you to learn and, to be very, very confident by 2 weeks. I think most of you are confident already that you have understood design patterns. Just some more effort you require to get used to it, and next 2 weeks and you will be very, very confident. Make sense?
Can you tell us the systems ones that we'll be designing in next week?
It is there in the curriculum, but I have the curriculum open. So IRCTC, chess, and elevator. These 3 we'll be doing next week. And the 5th week, we'll be doing recommendation system and meeting scheduler design. It is there in the curriculum. Just go to kirtipraswanicourses.com. Yep. Okay. Go have a very good weekend.
Can you once mention the systems also that you will be discussing in the in the Discord channel if possible, so that we can work in the weekend or studying it?
Open kirtipraswanicourses.com. But okay, I will paste it on Discord. You have not seen my site.
Hi, ma'am. Is there any pattern who is implementing scheduler or batch processing batch?
That is what you have to think, that what design patterns we can use in these systems. That is the homework that I'm giving you. You have to think in recommendation system, in meeting scheduler, in IRCTC, in chess, what design patterns can you use? Okay.
Thank you.
Yep. Okay. Have a very good night. Have a great weekend. Yeah.
Kirti, one last thing. For the systems that you'll be designing next week, you'll use which language, or you'll be doing it both because it's live. That's why.
I will not be coding live, by the way. I will code it in advance and I will code in both C++ and Java, as I've done with the rest of them.
Okay.
Yep. Okay. Go sleep. Good night. I hope you had a good time. Please don't miss any further classes. And I will be launching the DSA course this weekend. If you're liking the course and if you're interested in learning DSA, you can sign up. I will be sharing all the details. App is live, and also the certificates will be available. I think they're already available. I will send you a mail and I will tell you how you can download them. Invoices are available. Everything is available. If you need anything else, just message me on Discord. Okay, go. Good night. Have a great weekend. Bye. Bye, guys.